Hello and welcome to another lesson for A-level physics. Today's learning intention is to be able to solve Suvat problems. The success criteria for today is to identify Suvat quantities in a problem, to rearrange the Suvat equations correctly, and to estimate the area under a curved line using small change approximations. So the Suvat equations, also known as the equations of motion, are actually given to you on the formula sheet, but we do need to know how to use all four of these complicated equations. Now, the following equations can only be used when the acceleration is constant. So in other words, if the acceleration changes, increases or decreases, these equations no longer become valid. The four equations, as they appear on the equation sheet, are written as V equals U plus AT, V squared equals U squared plus 2AS, S equals U plus V over 2 multiplied by T, and S equals UT plus AT squared over 2. Now each of those has at least four variables in it, or they all have four variables in them. V stands for the final speed, U stands for the starting speed or the initial speed, A stands for the acceleration, which, as we've said, has to be constant for these equations to apply. T is the time, and S is the displacement. Now, to be honest, it's easier just to have a look at how these can be applied in different contexts within different questions. So I'm now going to take you through three different examples where these will be relevant in a question. So the first question is: a car has an initial speed of 2 meters per second when the driver presses the accelerator, which makes it accelerate at 3 meters per second squared. The driver stops accelerating after 5 seconds. What is the speed of the car then? So we've been told what the acceleration is. The acceleration is constant, so we can use Suvat. Now the easiest way to do this is to actually write out the letters of Suvat, S, U, V, A and T, and then actually write down the numbers that we know next to them. Although this does seem quite basic, it really is a good problem solving tool, and it is what I would expect all students to be doing in an exam. So if we look at the information that we've been given, we know that the initial speed is 2 meters per second. That means that the value of U has to be 2. I also know that the acceleration is 3 meters per second squared, so I can put A is 3, and this happens over a period of 5 seconds. So I know the values of U, A and T. Now we want to know the speed of the car after that 5 seconds, so that means that we want to work out V. Now if we look at the four equations that were on the previous slide, they are also on the formula sheet. We need an equation that has U, A and T in it, because that's the information that we know, and also V, because that's what we want to work out. And the equation that makes sense to use will be V is U plus AT. As we normally would do for any other equation, we now substitute the values in. So we would do 2 plus 3 times 5. Obviously we do the 3 times 5 first because that's a product, and that comes out as being 17 meters per second. That's a nice straightforward case because we don't need to do any converting of units, and we didn't need to rearrange any equations to get the final answer. Here's a second example. A vehicle accelerates uniformly, that means we can use Suvat, along a straight road, increasing its velocity from rest to 30 meters per second in 16 seconds. Calculate the acceleration. As always, we're going to write down S, U, V, A and T. You will see me do this in every question that we do because it is what you're meant to do to make sure that you don't get any numbers confused, and it helps you to work out what you have and haven't got. Now, I don't know the value of S. I don't know how far it's moved. Now, although there's no number written down, it does say that the velocity increases from rest. Rest means not moving, so the initial speed U is actually 0. I also know that it reaches 30 meters per second, which means that the final speed is 30, and it takes 16 seconds to do that. So we write those numbers in like so. I want to work out the acceleration, so I need an equation that has U, V, A and T in it. This is the exact same equation as last time, but we have an issue now because this equation is not written in terms of acceleration. So we need to make the acceleration the subject of this equation. The way that we're going to do that is, well, we've got u plus at on the right hand side, so we're actually going to take the u over to the other side, which means that we'll have v minus u equals a times t. Now, to make a the subject, I need to get rid of the t as well, but I don't take the t away because it's being multiplied by the a, so in this case I need to divide by t. So we actually end up with v minus u divided by t is equal to the acceleration. Now, in an exam, do you need to show every one of those steps? Possibly not. You could probably jump straight to a equals v minus u over t. We now sub the values in. V is 30, u is 0, and t is 16. So we end up doing 30 divided by 16, which gives us an answer of 1.88 meters per second squared. Now for part B, we want the displacement. So I'll use the equation S equals ut plus a half at squared. Now the good thing here is that the value of u is 0, so ut actually just disappears, so I end up just doing a half multiplied by 1.88, which was the acceleration from the previous part of the question, multiplied by the time of 16 squared, and that comes out with an answer of 240 metres. Now for the final example, let's have a look at this one. It says a train undergoes uniform acceleration from rest to a constant velocity of 35 metres per second in a time of 1 minute and 10 seconds. What is the total distance travelled by the train during this time? Exactly like we have done already, we start off by writing down S, U, V, A and T. But now we need to work out S, so let's look at what else we've got. It starts from rest, so U is definitely going to be 0, and it reaches a constant velocity of 35 metres per second, so V is going to be 35. Then I was told that the time is 1 minute 10 seconds, but remember that time is always used in seconds, so in 1 minute there are 60 seconds, so the total 60 add 10 is 70 seconds. Now I want the distance travelled by the train, so I need an equation that links S, U, V and T. So in other words, one that doesn't have A in it. If you look at the formula sheet then, the one that jumps out that would be most appropriate here is this one, S equals U plus V over 2 divided by T. So when we substitute the values in, we'd have 0 plus 35 over 2 times 70, and you can put that straight into your calculator now, and it will give you an answer of 1,225 metres. So now that you've seen the 3 examples, the best thing to do is to have a go at some practice questions. Obviously pause the video before you have a go at the questions once they're displayed, and then press play and I will talk you through the solution one by one to each of the problems. So for the first consolidation question, it says a vehicle accelerates uniformly along a straight road, increasing its velocity from 4 metres per second to 30 metres per second in 13 seconds. Calculate the acceleration. No surprises, we start off by writing down S, U, V, A and T. If you haven't done that, you need to get into the practice of doing that at the start of a Suvat question. We know it's Suvat as well because it says the acceleration is uniform. Now then, we fill in the information that we know. It tells us that the velocity increases from 4 metres per second. That means it starts at 4 metres per second and it gets to 30 metres per second, and that takes a time of 13 seconds. We want to work out the acceleration. So the acceleration will be the change in velocity divided by time, which means we'll come out with an answer of 2 metres per second squared. You could have done that slightly different to how it's written on the board. You could have, of course, started with V equals U plus AT. Then you would have reached A equals V minus U over T, and the answer would come out as being the same. We now want to work out the displacement. To work out the displacement, I'm going to use UT plus a half AT squared. Now that means that we've got 4 times 13 is what U times T is. And then we've got a half multiplied by 2 multiplied by 13 squared. Remember the acceleration we got from part A, and the answer comes out as being 221 metres. Well done if you got those correct. Question 2 says an electric tram sets off from rest and travels 103 metres in 9.2 seconds. Calculate its acceleration during this time, assuming it was uniform. Again, Uniform accelerations means we're going to use Suvat. It travels 103 metres, so S is 103. Now, because it's starting from rest, U is 0. And then it takes 9.2 seconds to do this, so T is 9.2. We want to calculate the acceleration. So I know S, U and T, and I will want an equation that has S, U, A and T in it. That will be S equals UT plus a half AT squared. Now that equation at first looks quite complicated to deal with, but we can make it a little bit more simple because U is 0, so U multiplied by T will just vanish. So we end up with S equals a half AT squared. That trick we're going to use a lot in future lessons as well to help simplify questions. Now we just need to rearrange this for the acceleration. So we will multiply by 2 to get 2 times S, and then I will divide by T squared. So that gives me A is equal to 2 times S divided by T squared. When we put the numbers in, we will do 2 multiplied by 103 and then divide that by 9.2 squared, which gives the answer of 2.4 meters per second squared. Question 3, the last consolidation one, says a car accelerates at a rate of 4.2 meters per second squared from rest for 6 seconds. Calculate the final speed. So we write down Suvat again. U is going to be 0 because we're going from rest. Acceleration, it tells us, is 4.2. It doesn't actually say it's constant, but the implication is that it is. And the time it takes is 6 seconds. So now we want to work out a value for V. The logical equation to use is V equals U plus AT. U is 0, so all we'll need to do is 4.2 times 6, which gives an answer of 25 meters per second. Now we're on to the standard demand questions. The brakes are applied to a tram travelling at 25 meters per second, and it takes 18 seconds to stop with uniform deceleration. What is its deceleration? Now remember, deceleration of course is just an acceleration where we are slowing it down. So we're still going to be using Suvat for this. The value of U is 25 and the value of V is 0. That's because it's coming to a complete standstill, which is why the final speed is 0. And the value of the time is 18. Now I want to work out A. Now I would expect to get a negative value for the acceleration because it is a deceleration. So I start off with V equals U plus AT again. Rearrange this for A. I've taken U off because we're adding that to AT, and then divided by T because that's being multiplied by A. We substitute the values in, so we'll have 0 take away 25 divided by 18, which comes out as minus 1.38 meters per second squared. If that's what you've written down as your answer, that's absolutely fine, but that technically means a deceleration of 1.38 because obviously deceleration implies it is a negative acceleration. Question 2. A cat runs with uniform acceleration from rest to 10 meters per second in 20 seconds. What is its displacement after this time? So we write down our Suvat again. It's gone from rest, so it's 0. U is 0. It reaches 10 meters per second, so that's V, and then the time is 20 seconds. We want the displacement. The equation to use here will be S equals U plus V over 2 times T, and so we substitute the values in. 0 plus 10 over 2 times 20. We come out with a value of 100 meters, nice and straightforward. Question 3. An aircraft lands on a runway at a velocity of 40 meters per second and brakes to a halt in a distance of 860 meters. Calculate the braking time. So to do this one, you should have written out Suvat already. So you should get S is 860, U is 40, and the final speed is 0 because it's coming to a halt, it's stopping. Now we want to work out the time, so I need an equation that has in it S, U, V and T. To do that, I'll use again S equals U plus V over 2 times T. Now this is quite an interesting equation to rearrange for T. I have U plus V all being divided by 2. So it would make sense to multiply by 2. So we will have 2 times S on the left hand side. I can then divide by what's left in the brackets, which is U plus V. So we'll end up with time being equal to 2 times S divided by U plus V. We substitute the values in I will do 2 multiplied by 860 and then divide that by 40 to give me an answer of 43 seconds. For part B, I would like to work out the deceleration or the acceleration. So we rearrange V equals U plus AT as we have done already in this video. And then when we substitute the values in, we should get minus 0.93 meters per second squared. Now we're on to the stretch and challenge questions. These ones will probably have taken you a little bit longer. It says a cyclist accelerates uniformly from rest to a speed of 6 meters per second in 30 seconds and then brakes at a uniform deceleration to a halt in a distance of 24 meters. Although it may not be apparently obvious straight away, we've actually got two distinct parts of this motion. We've got the part where the cyclist is accelerating to 6 meters per second, and then we've got a completely separate section where the cyclist is then braking to a halt. We will have to write Suvat out for those two parts independently of each other. For part A, we're dealing with the first part of the journey. So I'll write out Suvat for the first part of the journey. We go from rest to 6 meters per second in 30 seconds. And we want to work out the acceleration and displacement. So to work out the acceleration, we use V equals U plus AT, rearrange that, and we get 0.2 meters per second squared. The displacement should now be very straightforward because we can use ut plus a half at squared. Ut will just go away, it is 0, so we do a half times 0.2 times 30 squared, which gives us 90 meters. So that's the answer to part A. Now for part B, the second part of the journey, that's when the cyclist is then braking. So I'm going to write out a new Suvat this time. So the new Suvat will be 24 meters because it says he comes to a halt in a distance of 24 meters. He's already moving at 6 meters per second and then he brakes to a halt, so the final speed is 0. To work out the deceleration, I'm working out A again. So I'll use V squared equals U squared plus 2AS. To rearrange this equation, what we will do is take U squared to the other side and then divide by 2 multiplied by S. That will leave us with the acceleration on its own. So then we substitute the values in and it comes out as minus 0.75 meters per second squared. The minus, of course, telling us that this acceleration is actually a deceleration. I now want to work out the value of the time. So I'll use V equals U plus AT. Now that I've got a value for A, of course, that means that we get an answer of 8 seconds. For part C, it wants us to sketch a velocity time graph for this journey. Now we don't have to plot it, but I would like us to include on here the actual significant values of the shape. So we know that it reaches 6 meters per second in 30 seconds. So we should have that marked on the graph. The line should be straight because it accelerates uniformly. And remember, the gradient of a velocity time graph is the acceleration. So if the gradient is constant, that means the acceleration is uniform. We have a straight line. And then, of course, it takes another 8 seconds for it to come to a halt. So we have another straight line going from 6 back down to 0. And then finally, we want to determine the average velocity for the journey. The average velocity is just the average speed, so we would do the total distance that we've travelled divided by the total time that it has taken. Now, in the first section of the journey, we travelled a distance of 90 metres. We have to add that to the 24 metres that he travelled in the second section. So in total, he went 114 metres. It took, of course, 38 seconds to do that entire thing. So we would do 114 divided by 38 to give us an average velocity of 3 metres per second. The final stretch and challenge question, again pause the video if you haven't already done it and then press play. A cyclist freewheels from rest down a hill that is 120 metres long. By the time he reaches the bottom, he is travelling at 15 metres per second and we've been asked to calculate the acceleration. Absolutely no prizes for guessing what the first step of solving this is. We write out our Suvat. We know that the cyclist travels down a hill that's 120 metres long, so the distance travelled is 120. He comes from rest, so u is 0, and his final speed is 15. We want to work out his acceleration. The only equation that allows us to be able to do that is v squared is u squared plus 2as, and I need to rearrange this to get a value for the value of a. So, because I'm adding u squared to the term that's got a in it, I will just subtract that from the other side to give me v squared take away u squared. But I can't just take off 2 and s because they are being multiplied by a, so we have to divide by them to get acceleration is v squared take u squared over 2s. We then substitute the values in. The final speed was 15, u was 0, and of course the distance was 120, so the value comes out as 0.94 meters per second squared. It then says in part B, at the bottom of the hill, the road levels out and the cyclist brakes gently, coming to a stop in 30 seconds. And we want the deceleration and total distances travelled. So this is a separate stage in motion, so we need a separate Suvat now. His starting speed here is 15, because that's the speed he was travelling at when he reached the bottom. He comes to rest, so V is 0, and it takes him 30 seconds. We want the deceleration and the total distance travelled. We'll do the deceleration first. We will get minus 0.5 meters per second squared, and then we'll do the value of the distance travelled. Ut plus a half at squared gives us 225 meters. But that's the distances travelled when the road levelled out. We want the total distances travelled, and he went 120 meters down the hill. So we'd actually add that on to get a total distance travelled of 345 meters. I hope you've enjoyed this video, and I will see you in the next video where we apply Suvat problems to things that are falling due to gravity.